So in this example, they ask you to find the resistance across the not the voltmeter reading, which is also 100 kilo ohm. So you just treat the voltmeter as any other resistor of 100 kilo ohm. Just treat it as 100 kilo. So how to find this PD? Because when they ask you for the reading of the voltmeter means what is this PD? So how to find the PD? Very simple. Firstly, what you do is you combine these two together. So remember 100 and 100 kilo ohm in parallel gives you how much? 50, right now. So can I redraw this circuit as this? That means the 400 remains, but these two I make it as 50. Can, right? So once I have this resistance, so what is the total current in the circuit? So to find the total current in the circuit, I take the total voltage 1000 volts and divide by total resistance 450. You see that? So I get total current, which is this. So if the total current is 0.00222 here, what is the PD across this equivalent parallel resistor? So I'll take 0.00222 times 50. I will get this PD right now, which is 111 volts. Now, remember I also mentioned the PD across this resistor, which is actually an equivalent parallel resistor, is equal to the PD across each of the resistors in parallel that combine to give you this. So if this is 111 volts, these two will also be 111 volts. So this is also 111 volts. That's your answer. Okay? Now, firstly, for this question, they mentioned that one of the bulb breaks. So let's say originally none of the bulb breaks. So let's say the three of them still functioning. And I give you some values so it's easier to imagine. So let's imagine that this is 12 volts. Now, if this is 12 volts, then each of these will be also 12 volts because they'll be connected in parallel right now. So if this is all 12 volts, this is 12 volts, that means there'll be equal brightness at first. Agreed? And let's say the current in each of the lamp is 2 ampere, 2 ampere, 2 ampere. So what is the total current that the ammeter will show you? 6 ampere right now, because the current here will split to 1, 2, 3. Now when one of the bulb breaks, my question is, will this and this still remain as 12 volts? Yes. Definitely, because it is connected in parallel. So some people ask me, does the bulb brightness depend on voltage or current? Actually, it's a wrong question, because the bulb brightness depends on both voltage and current. You cannot separate them, because most of these questions, they will assume that resistance of the bulb remains constant. So therefore, V equals to IR. If resistance is constant, your V is proportional to your I. So if your V changes, your I will change. You understand? So it depends on both. So therefore, since the 12 volts is the same, what about the current here and here? It must still be the same. Because if resistance is the same for both, so from the formula I equals to V over R, since the V is the same before and after this one breaks, the resistance also same, so wouldn't the current be the same? So therefore, this will still be 2 ampere, 2 ampere right now. So that means what's the total current coming out of the cell is only 4 amperes. So the current will drop. But then people ask me, why would the current drop from 6 to 4? Now very simple. I was telling you about resistors in parallel. If you connect more and more of them in parallel, the total circuit resistance will drop. Correct or not? Okay, because you remember what we said, right? If you have 3 resistors in parallel, the total resistance of the entire circuit is 1 of the resistance divided by 3. Right? If you have 4 in parallel, then 1 resistance divided by 4. 5 of them in parallel, 1 resistance divided by 5. So the total resistance keeps dropping every time you connect in parallel. So wouldn't it be true that if I remove 1 resistor in parallel, then the total circuit resistance will increase? So if it increases, then your total circuit current will decrease. That's why it must drop. You understand now? The total circuit current cannot remain the same, because the total circuit resistance has increased. Okay now? Now if you connect them in series, then what will happen is, for example, some people ask me if you connect in series, when one bulb breaks, what happens? Now, the voltage, when you connect them in series, will be divided. So if one bulb breaks, then you have a problem, no current will flow, so none of them will light up. But assuming that it is shorted, shorted means it bypasses this. That means it's not a broken connection, but use a wire to bypass this. Then the same voltage will be divided to 2 instead of 3, so each bulb will be brighter. So when you connect in series, if one of them you remove, but you still maintain a complete circuit, then it becomes brighter. Okay, so it's not the same as parallel. For parallel, when one breaks, it still lights up. That's why most of the time, if they want the lights to still function, for example, like Christmas lights, right? After some time, 1 or 2 of the bulbs will break. But you still want you still want the lights to function, right? You must connect in parallel. Because if you connect in series, one breaks, the whole connection is broken, none of them will light up. And if, let's say, you bypass this connection, then you'll be extra bright, the other lamps, and then it will burn faster. That's why it's always in parallel. Understand now? Okay? Now, giving an example of this application. Now, another way of explaining this concept in parallel is like this. Now, when you were younger, right, and then you know these power outlets that you like to plug your stuff into, your charger, your TV into. Now, usually one outlet we will connect to a few appliances, right, using some extension sockets and plugs and all that. Now, but I'm sure you have been warned that you cannot connect too many into the outlet right now. So why? What is the danger there? Because they will say, oh, after you connect so much, then what was the danger? What they tell you? You'll short circuit. So how would it short circuit? Will it spoil your appliance? Will it spoil the power supply from Tenaga Nasional, the power company, or what? So let's understand what's happening now. Now, firstly, let's say this power outlet here that I have. So maybe I draw it out for you. So with this power outlet, let's say you connect it to your TV. Okay, you connect it to your TV. Connect to here. Then after that, you realize you want to buy a new speaker, okay, with a subwoofer. All right, so you connect it to here, then you plug in also. Then you decide you want a modem and a router. All right, then you also connect to here. So every time you're connecting, right, are you connecting them in series or parallel? Now it has to be parallel. Why? Because it needs to function at 240 volts. You see, like for example in Malaysia, right, our household supply voltage is 240 volts AC. So all the appliances that they sell in Malaysia must operate on 240 volts AC. So therefore, every time you plug it in, you must be 240 volts supplied to your appliance. If you connect them in series, then the voltage keep dropping. So let's say you connect your TV first in series, then you connect your speaker in series, then the voltage divide, then your TV becomes dimmer. Then you connect another modem and router, it becomes even dimmer, your TV. You understand? So it all has to be parallel. You understand? So they're all parallel connections. Whether you use the extension plugs that are one long one with 3 sockets each. Okay. Alright, some people buy this type. Some people just buy one with many sides. Alright, got here, then got here. Alright, so people say which is better. Now actually they are all in parallel. It doesn't really matter. It's just whether you want to be neater or save space or whatever. They're all in parallel. Understand? So what is the danger here now? I give you an example. Let's say you connect our first appliance. Let's say it is modem. So let's say with the modem 1 ampere current passes through. Then you connect your speaker. So your speaker needs 2 ampere to pass through. Then you connect your TV. Also then now it needs 3 ampere. So what happens is the current through each of your appliance is not affected when you connect more. That means if I connect another one, maybe let's say an iron to iron my clothes, the current here and here wouldn't change. It still be 1 ampere, 2 ampere, 3 ampere. Why? Because the voltage is still 240 volts. So the more appliance you connect, it doesn't affect the current in each of the appliance. But what it does is it needs to draw more current from the supply, which comes from the wire that comes from TNB to your house. Do you understand? So this wire here from the power company, all right, to your house, and then from your house to that socket that you have here. Now, which means to say it is the wire behind the wall, behind the socket. So if this was in the wall, So there will definitely be 3 wires running back to your circuit box. You understand? So the earth has no function except during leakage, but the live and neutral wires will carry the current. So when they carry the current, the more appliance you connect, the bigger the current in these 2 wires behind your wall. So what will happen is it will start to become hotter because there's power loss as heat in your wires called I squared R, and the higher the current that you need for the wires to carry, the thicker it has to be. Why? Because remember, resistance is inversely proportional to cross-sectional area. So if you want it to carry more current, you must use the thicker wire, because when the current is too high, that resistance would be significant and it becomes very hot. So the wires in our house are not designed to carry very, very high current. It's thick, but not that thick. So when the current is too high, it will start to heat up. When it heats up, the insulation around the live and neutral wires will start to melt. And remember, the live and neutral wires are actually very close to each other. So I drew it far away, but it's actually very close. It's together, inside inside a gray insulator. Then you cut off the gray insulator, then you see another 3 separate wires, right? Not something like this. All right, you'll see the gray insulator, and then inside you will have the live, and then you have the neutral. The live is usually the different colors. Then you have the so you got 3 different wires, right? So they're very close to each other. So what will happen is the wires will melt, and when they touch, that is called short circuiting. And when it short circuits, then an even higher current will flow, which means it's even hotter. So what will happen is, if your house is made of wood, then the walls are made of wood as well. So then behind this will catch fire. Do you understand? So that's the danger. But in our modern households, where you have a circuit breaker, you have these whole panels of circuit breakers. Remember, in your house there, you will see something like this. Got a lot of this that you can reset one if it trips. Right now, you have all these circuit breakers, right now. So what will happen is, if it shorts, that means if the live and neutral wire touches, then it will trip because the current is too high. You understand that? But it will not trip if it starts to melt yet. Until it melts and touches, then you'll trip. So when it trips, right, it sort of like prevents your house from getting burned down up. But then you have to replace the entire wiring that comes from that circuit breaker to your socket. You have to replace it because it's melted. You understand that? So that is the danger. Okay, so it's not to say like your whole house will explode, or your appliance will spoil, right? So you must understand what is happening.